Okay, in this video we're going to look at unsaturated hydrocarbons, which are hydrocarbons which have not got a full number of hydrogens around it, and so consequently the carbons inside the hydrocarbon have been either double bonded or triple bonded to each other. So the ones which have double bonds are called alkenes, and these are actually building block molecules for a lot of synthetic chemicals. They're very useful for their reactions because they are unsaturated. They easily pick up new reactants, and they can be used to make polymers, they can be used to make pharmaceuticals, so they're very useful, and they are also a byproduct of the processing of crude oil. So the basic alkene, the smallest one you can get, is made with 2 carbons because you need a carbon-carbon double bond, and it's called ethene. And we don't need to number anything here because there's only one way round of having this. Similarly, the next one along is propene, and we don't need to number this one either because if we rotate this, it's a symmetrical molecule. So the double bond between these 2 carbons is identical to it being between these 2. With the next one, we've got 4 carbons. So this is butene, and we need to number this one because it could be between 2 end carbons or it could be between the 2 middle carbons. So we number from the side with the important group. So the important group here is the double bond. So we start 1, 2, 3, 4, 5 over this way. 1, 2, 3, 4 over that way. So this is called but-1-ene because the double bond is between the first and second carbon. If we move along to triple bonds, this is when it's very unsaturated, and these are highly reactive molecules now. We have triple bonds between the carbons. So this is a double carbon, so we call it ethyne. Now these are called alkynes as a group, so this is called ethyne, often more commonly known as acetylene. Okay, and acetylene is used in blowtorches to react with oxygen in a very hot flame to help melt metal for blowtorches. So you've probably heard of acetylene torch if you've done any welding. This one here is 4 carbons long, so it's butene, and if you look carefully, you can see the triple bond could easily be between these 2 carbons, and therefore we need to number it as but-1-ine because it's on the first. If it was between the 2 middle ones, so you'd call it but-2-ine. If it was between the next 2, you'd call it but-1-ine again because you'd renumber it, and you'd start over this side, 1, 2, but-1-ine. Now, here's an example of a naming question. So the first one here, write the systematic name for the following molecule. Okay, so with naming molecules, you always start by looking for the longest carbon chain. Now you can see that's going to be the 5 carbons in a row there. And the fact that this is an alkene means that that's the sort of priority. So this is a pentene, is the parent molecule here. And the carbon-carbon double bond is between the second and third carbon. So if we just number the carbons from this side, we end up with the lowest numbers that we're going to use. If I was to number it the other way around, we'd end up having to use 4s. So we're going to number it this way around, and therefore we say that it's a pent-2-ene because that tells us that the double bond is between the second and the third carbon. Then we look at the substituent groups, which is a methyl group there, and the methyl group is on the 3rd carbon. So this part goes 3-methyl at the beginning as a prefix. The next molecule here, have a go at pausing this video and naming this one now. So once again, we're going to go and find the longest carbon chain. So we can see that is either this one, or you can go around the corner, but it actually makes no difference to the parent molecule. The parent molecule is a butene, and it's, if we're specific about where the double bond is, it's between the first and the second carbon, because we start numbering on the side with the double bond, and so it's a but-1-ene. Then we go and circle the functional groups, the substituent groups, and we've got 2 methyl groups here. So it's a dimethyl. They're on different carbon atoms, so it's a 2,3 dimethyl. 2,3 dimethyl butanene. Okay, now we're going to look at isomers. So what I'd like you to do next is I would like you to show me all the structural isomers you can think of pentene. So remembering that pentene as a regular parent molecule is C with 5 carbons. There. Remembering carbon has only 4 things bonded to it at any time, and not exceeding that. So that's the first one. How many structural isomers can we find? Pause the video, have a go at that. Okay, so here are the answers. So we can see here that the carbon-carbon double bond will move into the middle there. We can also have a branch coming off, so we've got 2 different methyl groups coming off there. So that's a 2-methyl butene. We can keep it as a butanene and then put a methyl on there. We can keep it as a butanene and put a methyl on there. So because of where the carbon-carbon double bond is, the methyl group can either be attached straight to it or it can be attached to the next one along. So there's lots of isomers. As soon as you include a double bond, suddenly there's a lot of structural isomers. Lastly, we're going to talk about the reaction. So I mentioned at the beginning of the video that alkenes are a crucial building block of a lot of different molecules, and the reason is because of what we call addition reactions. They undergo addition reactions by simply mixing with another reactant. There are many possibilities for what we can add. So for example, if we add bromine, Br2, it simply adds across the double bond like that. So you end up with a bromoalkane. If we add water with a acid catalyst, we can add it and turn it into an alcohol. So it easily becomes an alcohol. This is ethanol now. If we add acid, HCl, we can make it into a chloroalkane. So similar to the first reaction, but this is using HCl instead. Lastly, if we add it to itself, we can polymerize it and make a polymer, where they're all attached in a chain with n number of monomers long. So we could have like 1,000 in a row chained together to make a plastic polymer, which we often use in day-to-day household items. So that's the kind of importance of alkenes. In Unit 3 and 4, you look a lot more into the reactions there.